Welcome to your Intro to Stat Lesson 2.2. Today we're going to apply measures of variation to data sets. Okay, variables vary, okay, in statistical terms. If I'm interested in the height of young men age 18 to 25, there is going to be a certain amount of variability in those responses, in those observations. Otherwise, it wouldn't be a very interesting data set. So one way to describe a data set we talked about last time was the measure of the center, okay, to give kind of a typical value. Well, we also want to know how much all the observations vary from that center value, how much variability there is in the data set. Okay, so there's three measures that we're going to talk about. One is, for right now, one is the range, one is the standard deviation, and the third is the variance. The range is probably the simplest to figure out and the most straightforward. It's simply the difference between the largest and smallest values of a distribution. So if we want to find the range of the data set 10, 13, 17, 17, 18, we just do largest minus smallest. So we do 18 minus 10, and so we get 8. The standard deviation is a measure of the average variation of the data entries from the mean. Okay, it's not just max minus min, it's a measure of the average distance from the mean for each observation. Okay, and so the way that we do this is we do the square root of the sum. Okay, we're going to sum up something. What we're going to sum is that difference. Remember, it's the average variation of the data entries. So we're actually going to add up the sum of the squares of the difference between each observation and the average of that sample. Okay, so x minus x bar. So right here, what we have is what's called the deviation for each observation. The thing is if we don't square it, if we just add them all up, it always adds up to be 0 because of the way we calculate the mean. So to keep that sum from always being 0, we square it. Okay, then we divide by n minus 1, the sample size minus 1. That's something called the degrees of freedom. Now, here's the deal. Because we squared right here, we have to take this square root to get back into the original units of the observations. Okay, so here we've got our sample size, here we have the mean of the sample, and you're going to need to be able to use this formula. All right. So you have to be really organized to use that well. So to calculate standard deviation of a sample, you're going to calculate the mean of the sample, and then you're going to find that difference, the x minus x bar, the difference between each entry x and the mean, the x bar. These differences will add up to 0. Like I said, that's why you got to square them. So then the next thing you're going to do is you're going to square all those deviations from the mean, and then you're going to add them up. You're going to sum the squares of the deviations from the mean and then divide the sum by n minus 1 to get the variance, which we'll talk about again in a minute. And then you're going to take the square root of the variance to get what's called the standard deviation. Now, I will show you how to do this by hand, especially if you're not good about remembering to bring your calculator. You're going to need to be able to do this by hand. So you really want to pay attention to how to do it. So the variance is simply the square of the standard deviation. Okay, it's what you find along the way to get the standard deviation. The issue with the variance is that it's got different units than the mean or any given observation because we've squared but haven't taken the square root yet. And so if we're talking about, like I said earlier, the heights of young men age 18 to 25, if we were doing the heights in inches, the mean would be in inches, standard deviation would be in inches, but variance would be in inches squared. All right, so the variance of a sample is just s squared. S is the standard deviation. S squared is the variance. And if you notice, it's the exact same formula, just without this square root. All right, we're going to find the standard deviation and variance of a small data set, just 30, 26, 22. So the first thing you do, you're going to have 3 different columns. So the first thing you want to do is make your columns. You're going to have your X column. You're going to have your deviation column, just the X minus X bar column. And you're going to have your deviation squared column, the X minus X bar squared. And then whenever you have a column, you're going to sum it up. So first thing we're going to do is we're going to add up 30, 26, and 22, and we get 78. Now we want to know the mean, the X bar. So to get X bar, we divide by 3, and we just write that down. Mean, or X bar, equals 26. So now we're going to take each of these values and we're going to subtract 26 from them, and we're going to write that down right here. Okay, so 30 minus 26 is 4. 26 minus 26 is 0. That makes sense. That observation actually equals the mean, and so it has no deviation from the mean. It's exactly the same. And then we do 22 minus 26, so we get negative 4. For this column, we just take each of these values and we square them. 4 squared. Oh, before we do that, please note if we add all these up, the sum is 0. That's always going to be the case. That's why we have to go over here and do this step. 4 squared is 16. 0 squared is 0. Negative 4 squared is 16 because you would do negative 4 times negative 4. We add all that up and we get 32. Now, we're going to find the variance along the way before we find the standard deviation. The variance is S squared, and it's going to be the sum of the X minus X bar squared. We figured that out. That's what this is right here. We found each of these values and we added them up. Then we're going to divide by n minus 1. N is 3, so 3 minus 1 is 2, and so we get 16. The standard deviation is just the square root of 16, and so it is 4. Excuse me. All right, we're going to do the same process for a little bit larger data set. We're going to find the mean, the standard deviation, and variance of 4, 5, 5, 7, 4. So I write my 3 columns. I go ahead and list the data set under the X. Now I'm going to add them up. I get 25. N is 1, 2, 3, 4, 5. There's 5 values. 25 divided by 5 is 5. So the mean of the data set is 5. X minus X bar. All right, I'm going to do 4 minus 5, 5 minus 5, 5 minus 5, 7 minus 5, 4 minus 5. So I get negative 1, 0, 0, 2, negative 1. And again, if I add all that up, it's going to be 0. It's always going to be 0. So what I'm going to do is I'm going to square each one of these and then add. So negative 1 squared is 1, 0 squared 0, 0 squared is still 0, 2 squared is 4, and negative 1 squared is 1. And so we get 6. Now, the middle column is always going to add up to 0, so you don't actually have to show that. If you just want to get into like a little pattern of adding up every column, that's a good idea. But for one thing, this middle column should add up to 0, and if it doesn't, you've made a mistake in somewhere. You either miscalculated your mean or you made a subtraction error. So that's not a bad idea. But you really only have to sum up the first column and the last column. The first column in order to find the mean, the second column to have the sum of the deviation squared. Okay, the mean, the standard deviation, and variance. We've got a mean of 5, variance of 6 divided by 4, because the sum of our deviation squared is 6. The n is equal to 5, so n minus 1 is 4. So 6 divided by 4 is 1.5. The standard deviation is the square root of 1.5, which is approximately 1.22. Now, you can find all this out by using your calculator, and I suggest that you go through and try to do this using this last data set, the 45574. Hopefully you've written it down. So you probably want to pause the video a lot as you go through this. You want to open a document and add a list and spreadsheet page. Seriously, go ahead and do that. Now you want to enter the data in a list and have the list named values or observations, something along those lines. Go to Menu, Statistics, Stat Calculations, and choose one variable, statistics. Click OK for number of lists equals 1. It'll prompt you for that. Just click OK. And then there will be another screen. Just click OK for that. And then find the column with the results and scroll down, and it'll give you the mean, the X bar, the standard deviation is S. It's going to give you median, all kinds of interesting things. Okay. Another way of measuring variability is really kind of being able to say what proportion of observations you expect to find is using standard deviations away from the mean. Okay, so what good does the standard deviation tell us? You know, what is it? Why do we care? Well, it gives us an idea of a lower bound and an upper bound for a particular proportion of data. So Chebyshev's theorem is a way of stating this. So for any set of data, doesn't matter what shape it is at all, and for any number k greater than 1, so it has to be 2, 3, 4, or 5, something bigger, the proportion of data that lies within k standard deviations of the mean, so that means that many standard deviations above the mean and that many standard deviations below the mean, that proportion is going to be at least 1 minus 1 over k squared. Okay, so let's say we're interested in 2 standard deviations away from the mean. Then we would do 1 minus 1 over k squared, where k is 2. So we'd have 1 minus 1 over 2 squared, so 1 minus 1/4. Well, 1/4 is 0.25. 1 minus 0.25 is 0.75. And so in terms of percent, 75%. So according to Chebyshev's theorem, at least 75% of all data values will fall within 2 standard deviations of the mean. Okay, and that's for any kind of data set. So if you know the mean and the standard deviation, you just double the standard deviation, subtract it from the mean, and then go back and add it to the mean, and then you have a lower bound and upper bound for at least 75% of the data values. Okay, so let's look at that in action. A mathematics class completes an examination, and it is found that the class mean is 77 and the standard deviation is 6. According to Chebyshev's theorem, between what 2 values would at least 75% of the grades be? Well, we know 75% of the grades was related to 2 standard deviations below the mean and 2 standard deviations above the mean. So we want to go from x bar minus 2 times the standard deviation to x bar plus 2 times the standard deviation. So we're going to do 77 minus 2 times 6, and then 77 plus 2 times 6. Okay. So we're going to have 77 minus 12 to 77 plus 12. So that would be 65 to 89. So just knowing what the mean is and what the standard deviation is, we could figure out that, okay, at least 75% of the grades would be from 65 to 89. All right, next time we're going to come back and talk about percentiles and something called 5-number summaries for your data sets. For one thing, we really focused on standard deviation and variance. I mean, there's range that works for anything, but standard deviation and variance, because they involve the mean whenever you calculate them, they are used to measure the variance whenever you are the variability whenever you are working with the mean as the measure of this center. Well, what if it's a distribution where you work with the median? And typically with skewed distributions, you work with the median. What do you do then? Well, the 5-number summary is going to tell you what to do then to talk about the variation in those distributions. Okay, guys, do the problem to try on your own. Thank you for paying such good attention, and I will see you in class. I hope you have a great day.